Dear student, today we will discuss position and displacement vector in 3D, means in 3 dimensions. X, these are the X, Y and Z axes. This is the origin. Let P be a point whose coordinates are x, y and z. That its position vector is r. If we represent this position vector r in terms of its components along x, y and z axes, then we may write as vector r, position vector r equal to x I cap y j cap plus z k cap, where I, j and k are the unit vectors along x, y and z axes respectively. If we evaluate its mod, then it will come out as mod of position vector r equal to x square plus y square plus z square. Position and displacement vector in space. X, y, z coordinate axis. Let a particle is at point P1 at any instant of time t, having coordinate x1, y1, z1. After some time, that is at time t dash, it reaches at P2 having coordinate x2, y2, z2 respectively. Let position vectors of P1 and P2 are r1 and r2 with respect to origin. Then position vector at t of the particle is given by r1 equal to x1i y1j z1k, and position vector of particle at P2 is given by r2 equal to x2i y2j plus z2k, where I, j, k are unit vectors along x, y, z axis, and x1, y1, z1, x2, y2, z2 are the components of the respective vectors along x, y and z axes as shown. Then displacement vector. Displacement vector means P1, P2. A position P1, दूसरी position P2. We want to find here displacement vector during the time interval t dash minus t. The displacement vector P1, P2 during time interval t dash minus t is given by P1, P2 equal to R2 minus R1. Say it is delta, change in distance, change in displacement, change in position. Let it is represented as delta R. Now delta R, displacement vector, may be written as subtract करो तो R2 minus R1, ये हो जाएगा x2 minus x1 I cap y2 minus y1 j cap z2 minus z1 k cap. This is the displacement vector, and mod delta r equal mod of equal to x2 minus x1 whole square y2 minus y1 whole square z2 minus z1 whole square. This is the magnitude of displacement vector. Here we will discuss direction cosines. Direction cosines of a vector are generally represented by L, M, N. L x-axis, M y-axis, N z-axis. ये डायरेक्शन कोसाइंस है. डायरेक्शन कोसाइंस of a vector are the cosines of the angles which a given vector makes with x-axis, y-axis and z-axis respectively. Cosine of angle that a vector makes with x, y and z axes respectively. Let here it is alpha, beta and gamma. Angle vector A makes angle alpha with x-axis, it makes angle beta with y-axis and gamma with z-axis. Z-axis वो जहाँ प्लेन में हमने फॉर्म किया इसलिए ये z ऐसा आया है, वैसे ये z-axis इस तरह से होगा along the marker. तो ये z-axis ये कॉन्सेप्ट रहे. अब अगर हम इसको लिखें L, हमने कहा it is cosine of angle which a vector makes with x-axis. It is cos alpha, and cos alpha equal to base upon hypotenuse. Base x component ax upon a ax by a. One. Similarly, m equal to cos beta ay by a. N equal to cos gamma az by z. Now square of vector a square equal to ax square ay square plus az square. Squaring and adding equation 1, 2 and 3. We have L square, M square plus N square. L square plus M square plus N square equal to ax square by a square, ay square by a square, az square by a square. Now L square, M square, N square equal to ax square, ay square plus az square upon a square. इसके न्यूमरेटर को देखो दिया है ax square plus ay square plus az square which is equal to square of magnitude of vector a equal to a square by a square equal to 1. That is L square M square plus N square equal to 1. This is the direction cosine.